rover, could only get to a certain cross-track error on that, and so we've come over to ROSAG, trying to figure out how to use ROS packages, hopefully to automate a farm tractor with row crop planting precision, probably use with hay cutting, and trying to follow Matt's footsteps to start with the lawn tractor to get componentry working, and then try to upscale it to that's me.
Right.
Thanks, Al. Next on the list is Sohan.
Hi, Jonathan. I'm Sohan. I'm a master's student at IUPUI in Indianapolis. I've worked a bit here, a bit there. I worked on the AgBot project at our university. Done an okay job, I guess. And I'm just here to contribute and learn.
Okay.
Next is Kyler.
Hi, Jonathan. I'm Kyler Laird. I'm in Northwest Indiana working on field robots to run my farm, and now I'm pushing beyond the farm and working in other spaces. And I'm a safety nightmare, so I'll look forward to what you have to share.
Okay.
And Jonathan's next on the list.
Yeah. Can I put some slides together because I always find that helps me stay on topic.
Yep. Before you do that, maybe we'll get Sam's introduction and then we can go into your presentation.
Yeah, okay.
Yep.
Hey, Jonathan. This is Sam here. I'm here in Detroit. I mean, in Ann Arbor, actually, from Michigan. And I joined the ROS agriculture community to learn the ROS, and also I'm the big time open source enthusiast. So I wanted to actually, and ROS is basically an open source software. So together, just wanted to learn and hopefully in the future try and build some products which, the farmers can use around the world. So that's the goal.
Great.
Thanks.
So do I just hit share then, Matt? Is that?
Yep.
There we go. Share. Right. Can you see PowerPoint slides?
Yep. It's coming up.
So I've culled some slides from a seminar that we just gave recently to a group similar to you, trying to do robotics in cleaning machines. So indoor low-speed robotics, trying to keep the floors clean. And it was a full day session. So I'm not going to share all the slides with you, but we'll go through some of the more interesting ones. Hopefully you can still hear me.
Yep.
And hopefully you can see a slide with my picture on it.
Looks good.
Yeah, so my background is automotive. I've been an automotive engineer for the vast majority of my career. Most recently, I joined a company called Xaver, who are the largest functional safety certification group in the world. We're about twice as big as the next nearest group of organizations called the TUV. And we handle probably 5,000–6,000 certifications every year in automotive, process industry, a whole range of industries. And if you don't know what functional safety is, then I'm going to share a few thoughts on that for you. Typically what we do is we have a product like a tractor, and if we want to remove the driver, we'll spend a lot of time and effort allowing the vehicle to drive and do the primary functions, and somebody at some point will suddenly realize that hang on, we had a near miss there, and they'll start thinking about adding a safety or a protection system to shut down our operation in an unsafe condition. So with a tractor, it might be we didn't quite stick to the rows, or we started to wander off, or we had some meandering behavior, or it went onto the road, and somebody realizes that, that was not a good thing to happen, and we now need to start thinking about engineering a protection system. And that's the typical approach for most industries. They try something, they kill some people, and then they add the safety in. And what we try to do with functional safety is also consider the inverse problem, which is when failure to perform the function may also have consequences. And so a classic example of that would be the airbag in your car. It's got to sit there for 10 years doing nothing, and then on that 10th anniversary, you decide to have an accident. If the airbag doesn't deploy, you're going to be pretty upset with your car at that point, because it could potentially have either saved the lives of the people in the car or certainly reduced the severity of their injuries. And that's the problem space that generally we're dealing with in functional safety. And I'll talk about liability shortly, but it's not the same as liability. It's entirely possible to have a fully certified safety-related system and meet all the requirements of a particular standard, but still have a design that's unsafe and can kill people. That's always possible. We try our best to avoid that, of course. And so what could go wrong? Well, here's nature's engineer. It's the beaver. And even the beaver struggles sometimes to anticipate the way that the tree is going to fall. And there's a surprising number of these photos on the internet of beavers that have failed to get out of the way in time. And here's an example of a robot, probably the first one to commit suicide, and decided it wanted to go and drown itself. So these things do happen in the real world. And I'm actually in Houston this week doing a training course on automotive functional safety. And of course, it wasn't too long ago that a valve failed in the Gulf of Mexico, and there was a lot of money that was lost as a result of that. It's not unique to the industries I work in. Aircraft have this kind of a problem too. Here's an example of what we'd call a cascading failure. You can I got these pictures from Wikipedia. You can go and review the summary there yourself. Obviously, the airline industry go to great lengths to recover their products, even from the bottom of the ocean, to try and determine what went wrong. And it's certainly a part of their engineering process that allows them to achieve their very high levels of reliability. And amazingly, in this particular situation, where the fan disc cracked and severed 3 of the hydraulic systems, the pilots were actually able to arrange a landing just using engine power, and they managed to save nearly 200 people from the 300 on board, which is quite astonishing, really. About 100 people a day die in cars every day on the roads in America. Worldwide, it's about 1,000 people die on airlines, and so they're obviously doing something right in that industry to preserve life. Agriculture, it's about a person a day in North America, but if you think about the amount of road journeys we do compared to the number of agricultural vehicles and the number of hours and miles that those vehicles do, 1 a day is actually a lot worse than 100 a day in automotive. So agriculture is quite a dangerous environment to be operating in compared to driving your car. And we usually think of things as just chains of events. So if you take this gas tank here, I've got to retain some gas there. I need to start thinking about moisture and corrosion that can weaken the metal in that tank. And I've got an operating pressure, and both of those together weaken metal, and the operating pressure could lead to a rupture in my tank. And if that ruptures, then I'm going to have projectiles, and either that's going to damage the equipment nearby to the tank, or it's going to hurt the people. And we're going to start thinking about how can we keep the moisture away from the metal, how can we change the metal coating to resist the corrosion, where can we make it thicker to strengthen it, to protect it against the risk of overpressure. Could we arrange to reduce the pressure over time so that as the tank ages, we can still make use of it? We can certainly add a relief valve to reduce the likelihood of rupturing. We can surround it with an enclosure to catch the projectiles, and we could certainly isolate the tank and keep people away from the tank when it's under pressure. And this is the traditional approach to functional safety. We look at the reasons why things might fail, we look at the chain of events, and we start adding safety mechanisms to protect those. And that all works very well in the world of mechanical engineering, but when we get to electronics, we're in a very different world. The 787 had these lithium fires. You can see the smoke billowing out there on the ground of the Japan flight there. What happened was they anticipated that they might get smoke inside the cabin, and they had a ventilation system that was designed to vent the air overboard. But because the batteries were the source of the smoke, obviously the power monitor was checking for low voltage and started switching off systems and switched off this ventilation system, which was powered by the batteries. And so obviously the smoke built up, and we were unable to perform the primary function. And that's an easy mistake to make, and it was a mistake made by a big corporation like Boeing. And you'd think they have a fairly good and rigorous approach to their engineering there. In the standard space, there are 3 different worldviews on functional safety highlighted in red there. The parent standard for functional safety is 61508. If you are really interested in this, then that's certainly one to go and license from the IEC and send yourself to sleep reading. And they introduced this concept of safety integrity level. And a safety integrity level is a way of ranking how much engineering a particular solution needs, because what we don't want to do is waste time and effort over engineering parts and failing to get to more critical parts as a result of that. So we rank and prioritize things, and we apply the appropriate level of rigor based on the risks. Automotive have their own standard ISO 26262, and they use the automotive safety integrity level. They have 4 levels, A, B, C, and D. And machinery might call up 13849, and they use a concept called performance levels for ranking their risks. In agriculture, you've got a couple of standards. You've got 25119 for agricultural machinery, and the 18497, I think, is in FDIS now, so that one's about to be released, and that provides some guidance on dealing with highly automated agricultural machinery. Again, one that you might consider reading. And so we have some definitions that have been agreed with the lawyers to help us. Harm is a reason we might send somebody to hospital. The hazard would be the source of the harm. We can't cause harm unless we have a hazardous situation. So to get a hazardous situation, we have to have somebody in the presence of harm with a hazard present, and they have to interact with that hazard to get hurt. And risk is the combination of the severity of the harm that might result and the likelihood or the probability that they might get hurt. And we use that to rank and identify the risk reduction that we require from our engineering measures. And so we might look at that as a graph like this. Tolerable risk is an arbitrary line somewhere in there. It does have a definition. Tolerable is about the likelihood of being struck by lightning. Anything more likely than that is considered by the courts to be intolerable, and we have to deal with that. And so we might have an acceptable and an unacceptable area. So if we rank our frequency of probability and our severity, we would find a point on the graph which would be our risk. And if that's above the line and it's not a tolerable level, we need to take steps to control that and reduce that risk. And if we decide to reduce that risk with electronic measures, then we're in scope of some of the safety standards which give us guidance on how to make sure our electronics can be relied upon to reduce the risk of failure, especially when that failure can cause harm. And it's expected that engineers will follow state of the art, and should you be called to account for your actions because you've hurt somebody, then likely that's going to be in a court, and you would need some evidence to show that the products that you've created and operated have been engineered correctly and don't present an unreasonable risk to the people using them or the people near to them. And so at the bottom there, many engineers are familiar with the specification and implementation, doing things, creating things. And most engineers understand that we've got to verify and validate those things. We've basically got to test them. When it comes to functional safety, if we're making things that can hurt people, then we need to plan some safety activities. We need to define what our concept is for safety, conduct a risk assessment to identify where we might get hazards, and then make sure that we engineer appropriate risk reduction measures using our normal engineering processes. And that green line there would essentially be a safety argument, that body of evidence there that shows that we've done our due diligence, that we've thought about what can go wrong, that we've engineered correctly and followed best practice and state of the art, and that we've tested is all valuable evidence that we would submit to the court and hope that they find that we've been reasonable in our approach. So another way of looking at the standards, this is something you can go and play with online from the Bosch group at Rexroth. You can go and type in your various standards that you're interested in, and the orbits there will tell you whether they're a basic risk assessment standard like 12100, which applies to everything in the world. The type B standards there are standards that apply to specific types of technology that we might choose to use for risk reduction. And then the type C standards on the outside edge are guidance for specific sectors. So you can see road vehicles 26262, and you can see the ones that you might be interested in, 15998 and 25119 for earth moving and tractors and machinery for agriculture and forestry. Now, any court would look at that as being state of the art, and so if you're not going to follow those, then you need a very good argument for that, and you'll need an argument that will survive the scrutiny of a court. There's a very interesting development going on in automotive because of this drive for higher levels of autonomy with the vehicle, up to and including not having a driver. And SOTIF, Safety of the Intended Functionality, considers this kind of problem space where what we want to do is maximize area one, which is things that we know to be safe, and the areas that we know are unsafe or that we don't know about yet, and clearly area 3 is potentially quite large in autonomous vehicles because the planet has never done that before. Obviously, we want to try to move towards a goal where we improve what we know is safe and we minimize what's unsafe and what we don't know about to a reasonable level. And that's the goal of this publicly available specification that's in development at the moment. And consumes a fair amount of my time and my colleagues' time arguing about this and discussing this as we try to guide the engineering of autonomous vehicles. We can't escape the basic reliability equation, though. At some point, our parts will fail. And this equation here really tells you that if you want to estimate a point T and whether your component will survive to that point, we've really got to understand the probability distribution of the failure of those parts. And what we need to understand to solve that equation is the field of operation. And some thoughts on the field of operation. You might want to consider the type of people operating your equipment. And if you've got trained people that are familiar with the machine and the hazards, they're going to be your most competent operators. You might have people present who are paid to be there, but maybe not familiar with the machine or its operation. And it's certainly reasonable to expect that there might be some public present on or near your farming area, although I guess that's less likely in some of the farms in North America, which are literally the middle of nowhere. And we might want to start thinking about those people because they're the people that can potentially get hurt. People come in all different sizes. Some people have disabilities. They can't see very well, or they can't hear very well, or they can't move very quickly. and we certainly get old people that behave in strange ways, and certainly young children behave in strange ways, and people in the middle like myself can be inattentive at points in time. And this presentation was given to the cleaning, and I just changed the title, but in cleaning we need to think about people that are carrying children either inside them or in their arms, or have got them in a cot or a stroller. And some people might have their children chained in some situations, of course. And we do expect in the cleaning environment to have animals to deal with. And I'm not sure that's particularly a concern in agriculture, but certainly we can expect animals to be present. So we have to anticipate this field of operation. Do we anticipate people who are not trained to operate or be curious about the machine? How are we going to transport it? Is that going to involve an automatic mode? A good thing to understand for your machine is whether the mechanical brake is sufficient to overcome full throttle. In an automobile, that's certainly the case. The brakes are always able to deal with full throttle. That's not necessarily the case on tractors, and certainly older machines struggle with that. You need to think about the gradients you're operating in, whether you're going to be doing random software updates. It's necessary to think about the types of obstacles that you're going to expect in your environment. Some sites have got OSHA provisions in place because OSHA have already had a concern with the safety of people at that location. And you might want to think about some of the environmental considerations like explosive environments or dust or ice or condensation and all the other good things that you get there. Probably insect storms is an interesting one for you. If you're cleaning inside, then you need to think about fire doors. We certainly don't want to be stopping in front of fire doors. And cleaning machines have got to deal with voids and edges and escalators and all those good things that you find in shopping malls. And so this field of operation really is something that we need to think about and look at the types of hazard that can occur in that environment. And I've got two videos here that I hope are going to play. They really show the, let me put this on mute. Yeah, they show, on the left here, this is a tanker that the driver's getting a bit upset here because he's tried to stop the flow of fuel into the tanker, but the fuel is not stopping and it's starting to overfill the tanker and come out the relief valves at the back there and spill on the floor. And on the right there, we've got a what's called a concrete buffer, and evidently the e-stop is out of reach at the moment. Now, I'd argue that on the right there, that concrete buffer that's rotating, that's not an unsafe condition. That buffer could keep on rotating there until the gas tank runs dry, and it's not going to actually cause any harm there. But as you'll see, they attempt to hurt themselves in rescuing the machine. I'm not sure what the water is intended to do, but anyway. Now on the tanker on the left there, you can see that we're getting quite a serious spill here. Yeah, tripping over and running is not a good strategy. This is a known hazard. I mean, I think even these guys who spend their time at this gasoline depot, they can probably still smell this gasoline. It's a known hazard, and here we see an example of how humans deal with clearly a very well-known hazard. And you can see the leak is getting quite significant now as the pressure's building up in that tank. I'll let this one run because I don't know whether you can read it, but we get a few more people turning up, and you know, I mean, I'm not sure the wisdom of tiptoeing through a pool of gasoline. Here's another person who decides that he's going to go and stand in the lake of gasoline now. And of course, inevitably we get management involved, and so now we'll have a conference, you know, a meeting. You know, these guys have been smart enough to stand at the edge there, but again, we've got a lot of people very close to this very dangerous spill. Send a cyclist through there. Go and have our gathering and our meeting in the pool of gasoline. I'd like to think that I'm one of these guys here that decides to stand at the edge, but I'm pretty sure I'm just average, so I'd likely be in the middle of the action like everyone else there. But you can see two people have decided to wait at the edge of the flames there. The guy on the bottom right now, he's beginning the washdown operation. So they've obviously realised they need to try and dilute this petroleum as fast as they can. So they're going to try to spray some water on it, and we're going to send another tanker close to the danger zone, just for good measure. Another tanker will go by shortly as well. So, it's very easy for these mistakes to be made. And why is that? Well, you saw some human behaviors there. We do this all the time in engineering. We might make some measurements and have a solution that does some calculations and then acts on that and drives or steers or brakes. And obviously there's disturbances that can come into our solution that can cause a deviation from our intended function. And we can also get faults within our solution. They can occur either randomly or they can just be faults in what we've created. The hardest thing to deal with is missing features. If you've got software engineers that are racing to create new software, evidently, if they're not asked to create the necessary features, especially the ones for safety, no amount of software coding will fix that. We've just got features that are missing from our solution. And again, functional safety is concerned with identifying those missing features and hopefully reducing the likelihood for random faults. This is maybe a bit too much detail for you at this stage, but we'll go through and analyze the risks. And the reason for that is because you could wind up in a court. And, if you're operating a single machine on a private farm, clearly your risk is going to be quite low. You're potentially going to be hurting yourself or your family or your friends. But if you do decide to hire people and you do decide to employ people and give them the task to operate that with machinery, and they hurt themselves, then you've got to expect a complaint from their family, because their family don't expect their loved one to go to work and die or get hurt. And so what the court will do is they will resolve an argument, and your argument will be that you did what was necessary and what was safe, and the plaintiff's argument will be that you weren't reasonable and the system was unsafe. And so the court will ask to see the evidence to make sure that your conclusion that the design was safe is supported by the evidence. If, like Homer here, you've got no evidence and no clue, pretty well the court is going to throw you out at that point, because either you're incompetent, ignorant, or lazy. And if you're one of those three, the judge will just simply dismiss the case and finding the plaintiff's failure. And then you'll go to arbitration to agree a 6 or 7 figure sum of money to pay the plaintiff for the harm that you've caused. If you can get past that point, then they'll start to take a hard look at what you've done, and they'll look for the outlying tests and make sure that you have addressed all the open issues and the actions and the concerns that the people doing the design have come up with. And they'll also ask whether the people who have been creating this product have got the expertise needed. A logical way of dealing with that is to hire qualified engineers, hire people that have the relevant degrees and the knowledge and understanding of the parts and the products they're creating and the failure modes, and to make sure those people remain current with what's state of the art, that they take part in conferences, that they take part in meetings like this one, where you get a group of people who have got a similar interest together to share their experiences, to make sure that they learn from each other's mistakes and each other's best practice. And you don't need to have letters after your name for that, but certainly it helps to convince a court that you've got the right people on the team if you've got people who can demonstrate that they take part in those types of activities. Of course, you could also come to an expert witness at the court, and the court will ask a company like Xaver to say whether the evidence that was provided was sufficient, whether it was the product of reliable principles and methods, and more importantly, whether those principles and methods have been applied correctly. Clearly, expert witnesses can sometimes help us and sometimes they don't. And the hard thing for engineers is that court doesn't generally concern itself with whether the product is safe or not. They're not really interested in that. They recognize that we can't have 100% safety and advance the civilization. The courts are interested in whether what we did was reasonable whether our evidence was reasonable, whether the information provided and used and the analysis performed was at its core reasonable. And that's sometimes very difficult for engineers to grasp, because engineers like to deal in certainties, and obviously the court is expert at dealing in this grey area of what's reasonable. So you'll build up your body of evidence, and the key documents that the court will likely call for would be the failure mode and effects analysis, which would be a list of things that can go wrong, your design verification plan or your test results, and the hazard and risk analysis itself, where you've identified the hazards that your new product, your autonomous tractor, is going to cause. And I think the rest of the slides here are a bit too much detail for you. So I'm going to stop there. And if you're all still awake and coherent, I'm more than happy to go back to a slide or to answer questions, or switch off and go away now, whatever you need.
Thank you, Jonathan. That's a lot of material, and appreciate you breaking it down. I always find it fascinating how you can take a complex subject and you just go step by step to explain the process.
Yeah, thank you, Matt. I have done it a few times, as you well know, so that always helps. Yeah, so I mean, it's a tremendous amount to take in. I mean, without doubt. I can't change that. What you're dealing with are very complex systems, but the other end of the day, you're also dealing with something that humans are very passionate about, which is getting hurt. People don't want to come to work to get hurt, and so yeah, there's a lot to take in there.
Are there any questions about the slides or functional safety in general?
I have one.
Yeah.
So the questions around the autonomous vehicle, I mean, not what we're driving on the road, but just a lot of progress is being made for the agriculture machines at this point, and there are a lot of projects that I can see. They claim to be autonomous, and they are working autonomously in the farm, in the field, and I'm not sure if there are any functional safety standard or ISO standards available at this point to go by if something happens. What if, and an autonomous tractor just go out of control, no switch, remote kill switch, nothing works, and just go across the highway and then get into the accident? So what happens at this point? Do we have any standards around that, and how would that scenario be tackled?
Yeah, there's two ISO standards, 25119 and 18497. The 25119 is for tractors as we know them with a driver, and the functional safety requirements for a tractor with a driver on board. And 18497 envisages machines that don't have a driver on board, and has the state of the art for those kind of machines. It's quite an interesting question. What happens when the tractor goes off the road? Currently, if you have a non-autonomous tractor, then at least in North America, there are provisions in the federal standards for what's allowed to go on the highway that make exemptions for farm machinery doing short transition runs across a road from field to field. So you're not allowed to go to the gas station, but if you're traveling from one field to the next and you're making a short excursion, then you're exempt from the legislation and the functional safety standards that apply to passenger cars. With the exception of California, and I actually pointed this out to them, because in California, what they've done is they've created a new set of legislation that gives manufacturers the ability to apply for and get permission to operate autonomous machines on the highway. And the provision for tractors is missing from that. And what the California legislation actually says is, if you even if they're that apply for permission and have agreement from California, can you still hear me? It says my connections and stuff. Oh, good again.
It paused a little bit.
Yeah, so you need to have permission. So if you go and fit an autonomy kit to a tractor, then in principle in California, the new autonomous vehicle legislation means that you're not allowed to use that on the highway anymore. Now, whether they'd actually go after you or not, I don't know. But for sure, if you'd hurt someone and when there was a complaint, it'd be a mechanism for them punishing you in the federal courts for failure to comply with DMV regulations.
I see.
I expect that to change. I expect the ag lawyers will argue for exemption again, but that's the current state in California at least. So generally, I think you probably know what happens today. If you have a tractor that's involved in an accident, we had a customer a while ago, and he explained to me what happened. So they reckon the driver fell asleep. The tractor went into the telegraph pole, rode up the telegraph pole, flopped over backwards, and the driver was hurt. He wasn't killed or anything. And the lawsuit went after the telegraph pole company. It went after him as the operator of the tractor. It went after the tractor company. It went after the owner of the field. And they went after all four entities there, and they sued the whole lot of them. And every single one of them chose to settle out of court, and they got a big payoff from all of them. And with that money, they sent in a vexatious lawsuit. Again, you've got a lawyer there who's happy to fight a case with no win, no fee, and the plaintiff's got some money there and doesn't care and gives them $500,000 to say, go and see if you can make that into $5 million as investment. I mean, it's crazy, but that's California. Which are any of you operating in California? Because if you are, I would suggest you tread very carefully and put up some big fences, or maybe move, because it's probably the most litigious environment you've got.
Huh. Okay. Yep. No, makes sense. Thanks, Jonathan.
Yeah, so 25119 and 18497, and I don't know if you can get your company to pay for them. I think the work of ISO is generally a good thing for the world. So I mean, feel good about maybe consider it a charitable donation. I mean, the standards cost a few $100s, but they're good value for money, really.
I see. And he said the 18497 is for the autonomous...
highly automated or agricultural machines, yeah.
Perfect. Thank you.
Jonathan, I know you're not an attorney, but can you just comment what you've seen about the insurance company's role in all of this? So let's just say, for example, I've got, generic liability insurance. Is there buried in there waivers around this kind of stuff, or does that offer any protection?
No, in fact, it's the exact opposite. So if you read the small print carefully, then you have some obligations. It's carefully worded legal speak, but the word reasonable will appear in there. Behaving in a reasonable manner, following reasonable best practice, that might be in there. And certainly when it comes to the underwriters for your particular policy, they will expect what you need to do is you need to go back to your insurance company and say, I'm experimenting, is that included in my general terms and policy? And, you may find they don't care and they let you get away with it. On the other hand, if you are doing that kind of thing, they'll expect you to be following state of the art. And the reason they do that is because the underwriting bodies, that's part of the basis of their risk assessment, is that you're going to be following state of the art, that you're going to be reasonable in your activities. And so the first time you make a claim on your general insurance policy for an event, you know, they may decide to fight that for you and say, you know, slap you on the wrist and say you should have told us, and here's your new policy with the new wording and the associated premium increase. Of course, be paying your you know, whatever that sum of money's called that you have to pay. I forget what it's called, the deductible. But of course, if you have a second instance or a third instance, eventually they're going to have to go to the underwriter to fund that, and the underwriter may just refuse, and that means that you won't be able to get insurance. And so, you know, what the large organisations do is they will work hand in hand with the industry association. The industry association includes the insurance underwriters, and they will work together to make sure that the insurance underwriters are comfortable with the risks and the approaches that are being taken by the manufacturers, so that they can insure the people using their products. Because obviously, if you want to sell a product like a tractor and people can't get insurance for it, then, you know, that's the end of your business, really. So, yeah, I mean, you're going to have to read the small print. And you're right, I'm not a lawyer, but I've worked with enough lawyers to to know generally how these work from an engineering point of view.
Okay, thanks.
Colin, I don't think your mic is on. We can't hear you. Or bring your mic down from your headset. Nope. Can't hear you.
The lip read.
No.
Can you use a chat window if he has any questions?
Yeah, you can type in the chat window, or you could, you may need to log out and log back in.
I got to drop out, but I want to say, hey, Jonathan, what's up, brother? Been a long time. Thanks for all your awesomeness. This is Walter, BT Dubs.
Hello, Walter. Yeah, nice to hear from you again.
It's amazing what Matt brings out of the woodwork, right?
It really is. What a small world.
Very true, very true.
You're leaving now, are you? Well, nice to hear from you. Stay in touch.
Yeah, definitely, man. Keep it real.
Wally G.
That's funny. Colin, he's a farmer down in Zimbabwe, but I don't know what's going on with the mic there. Still can't hear you.
Jonathan, on one of your last slides, you mentioned, you know, if you did get into litigation, they would be looking for a couple of deliverables. I mean, no doubt those things are expensive to produce, and companies probably keep those things close to their chest. But have you seen anything in the public domain about, I think you called it failure mode analysis? There were two deliverables that you had on your slide, but anything in the public domain that you think we could leverage, of people that have thought through, you know, what are the bad events and the mitigations on those?
Yeah, so the three I mentioned was the hazard and risk analysis. That's the document where you spell out what you think could go wrong and cause harm. The FMEA, the failure mode and effects analysis, and that's just a systematic tool for identifying ways in which your product can fail. And then your design verification report, which is the summary of the testing that you've done to check that the product performs as you intended. And I mean, I'm sure I know they must be in the public domain, because certainly in automotive cases, they get called all the time. It is possible that they do get a request to keep them confidential. And I haven't particularly looked, but I'm sure I could find some examples of FMEA. It's not a very difficult analysis to perform. and they're costly usually in time more than anything else. But of course, if you can identify some problems up front and it can save you, a settlement, then they easily pay for themselves. It's just very hard to justify that up front because you haven't experienced the pain of being sued. FMEA is widely adopted in the automotive industry, so there's plenty of courses and examples online of how to conduct an FMEA, for example. Test reports, you don't particularly need any guidance on that. It's what you learnt in physics class. You write down your apparatus, you write down your method, you write down your results, and you write down your conclusions. Testing is as simple as that. The HARA is a bit more of a specialized activity, and I'd be happy to spend half an hour and share that with you so that you understood how that tool worked. And it's not difficult to put together. It just needs a bit of effort to think about it. So yeah, and you're right. Obviously, when you write down what can go wrong with your design, certainly John Deere and Caterpillar would consider that absolutely top secret, because they don't want either the other company to find out what the weaknesses of their product are.
Okay, thanks.
Yeah.
Hey, Jonathan, I have a question. So I was, while you were presenting these, and I'm looking at these FMEA. I've learned about it in some of the courses that I'm taking, and I like the systems approach here. But I was wondering how everything that you had just mentioned relates to an open source, because there have been I know of this example where they had these blood glucose monitors, and if there's a big company like I forgot the name of the company, but let's say there's a health company. I know they make these blood glucose monitors, but there's also a big open source push in that area. How does, big companies have to spend these monies on such analysis and everything because they fear litigation, but because they have money, they can afford. I feel like people sue them because they want to get money out of their those litigation, but in as compared to open source, where there's a bunch of individuals working on different things, and there's always a BSD license or something, a clause involved that says, this system has no guarantee. You work on, you use it at your own risk. How does that relate to what we just discussed at the presentation today?
Well, a court would look at the facts, and the facts would be that someone somewhere has used an open source software library. That's a decision that somebody made, and if that open source library was not appropriate or fit for purpose, or had failure modes, then the use of that is the responsibility of that decision maker. And it would be sensible of people using software projects like that to look at the quality of that source code, to make a determination whether there's failure modes with it, and to make a determination whether their testing is sufficient to take account of the unknowns. Especially with open source, it's completely unclear whether the developers of that code had your application in mind. And if they didn't have your application in mind, or they created bugs or faults in that software, and your application is sensitive to those, and your application as a result of those bugs causes harm, then the court will go straight back to that decision. Why did you choose to use open source software? And you need a good argument for that. And if your argument is it was free, or if your argument is there was no other choice, or if your argument was that was the best solution at the time. Depending on what you say there is going to determine how the court view your choice there. If you say to them, well, it was free and it sped up my development, and I thought about what could go wrong, and I was careful in the way I implemented it, and I identified the things that could go wrong, and I did testing to make sure that my particular version of the open source project that I compiled and my particular use of that was safe. That's a much better answer than having no evidence and no data to support your argument. And really, that's the sort of cost benefit with open source. It certainly gets you a big head start, but the responsibility for safety is now all on you and your use of that, and the wrappers that you surround that open source with to deal with the potential failure modes that you're unaware of exist in that piece of software. So if you're used to just taking a piece of software, the latest version, and just launching it on the tractor, maybe you want to change your development approach and maybe stick with a version and fully understand it and fully test it before you begin your development process again on a new version, and repeat those tests, to make sure that your product remains sufficiently safe. And there's a lot of effort going into Linux at the moment in the automotive industry, because there's a feeling that it's going to be a necessary component of safety systems in the future, because it's just such a versatile operating system. But that doesn't release you from the responsibility of understanding it and dealing with its potential failure modes. I think have we got a question on the screen there? I wonder if I can read that. Did that answer your question?
Yes, I think it was a great insight. I never thought of it that way, and it's another area that it did answer my question.
Yeah. So yeah, Jonathan, can you comment on the cyber risk as a cause of accident? I can. A number of my colleagues have been taking part in a new machinery standard, 62443, which again the court would consider state of the art when it came to cyber security. I think in general, if you're a single user operation in a single field, the rule of thumb with cyber security is that you need to assess what your threat vector is, and obviously, I think an individual attack on your product is more likely that that's going to be a person or a neighbor who's disgruntled with you or upset with you than, say, a state actor. But if you're like John Deere or CNH, then the number of vehicles that can be disturbed by a cyber attack might become interesting to somebody at some point. But generally, I think there's not a lot of bragging rights to be had by stopping tractors in the middle of the fields doing something, compared to taking Facebook down or taking Amazon down. So, in terms of prioritizing your risk, that would be how we'd think about it. Does anybody have opportunity for the cyber attack? What's the reward for them attacking your particular solution? And how many products are available to them to mount that attack on and learn how your product works? And while you're in the ones or twos and in the middle of nowhere, you're not really going to rise up the list of desirable cyber attack targets. But yeah, if you are subject to a cyber attack and somebody causes harm as a result of that, then it's going to be very difficult for you to prove that it wasn't a fault in your system, especially if you get an expert witness ask some basic questions about your approach to cybersecurity. So certainly a thing to keep on the future radar. If you're successful and you dominate the world, then maybe you'll become attractive to people for a cyber attack. In the meantime, just don't upset your your neighbours and co-workers, because they're more likely to want to mess about with your system than anyone else, or your children.
It's true. Any more questions on functional safety, or any other questions for Jonathan?
Well, if you wake up in a cold sweat in the middle of the night worrying about this, send me an email with your questions, and I'll do my best to point you at the answers.
It's a big topic. There's a lot to it, but thinking about what you're working on, writing down why you're doing what you're doing, and just take a moment to think about what could go wrong with the system. Just
Yeah,
being diligent through the process as you're making it.
Exactly. Yeah.
Jonathan?
Yeah.
I do have a question. I mentioned that I have nightmares about safety. I do wonder, especially coming off of your experience with cleaning machines, is there some sort of standard for what presents a hazard to humans as far as size, speed, some combination of that? I assume a Roomba is considered to be fairly non-hazardous, at least if you're not a cat.
Yes, there is. And if you give me a moment, I will try to find it. Where is it? It was a study commissioned by the a consortium of German insurance companies, and they basically took measurements in a medical setting of the various parts of the human, and what they did was they established what was what was acceptable and what was unacceptable for force and pressure and repetition rate on different parts of the body. And I think I might be able to find it. Here we go. Yeah, so force, pressure, and velocity limits for different parts of the human body, and they came up with a. Now let me share my screen. That one. Share. So do you see this table on the screen now?
I do.
Yeah, so it's been captured in an ISO technical spec 15066. So you can see here what the maximum permissible pressure on the middle of the forehead is 130 pascals. So there you go. And you also deal with transient contacts, and they have a formula here that tells you what the formula helps you work out what the limits are, worst case scenario. And so, yeah, 0.23 of a joule on your skull is the max that the doctors would say should be allowed, and anything more than that is obviously going to lead to some form of harm. So you can see your back and shoulders do pretty good. Your pelvis, obviously, the best. Obviously, that's the main load-bearing part of the human body, and your hands and fingers are pretty delicate at the end of the day.
Great, thank you.
Yeah. So that's. Did you get that standard there? 15066. So you'd have to work out your velocity, your impact velocity. You'd have to work out, you know, the softness of your surfaces. Obviously, if it's a lump of metal, it's not going to be very soft. And you know, I think with a field, you can be. You know, one of the things we're really concerned with cleaning machines is that we've got a wall or a pillar there, and if you've got a stroller, then these machines are more than strong enough to crush a stroller and a child that might be strapped in there sleeping. Whereas with a field, you know, I think. Well, I mean, the one that they were concerned about with the highly autonomous machinery was that you'd get someone who was adjusting or attaching an implement on the back, and obviously, if the machine moves towards them, then you know they're going to get crushed between the implement and the tractor, and that's not going to end very well. So that's the primary concern with that standard is ingress and egress to the machine. You know, how do you arm the machine and get away safely? And if you've got a machine in an unknown state, how do you make sure that you can approach it to take back control again and do that safely? So they're concerned with sensing humans that are trying to approach the machine or leaving the machine. Are you dealing with full-size tractors? What saw the video that Matt shared me, and it was. I mean, I think it was the demonstrator, so it was obviously quite a small machine. But are you dealing with full-size machines here?
I deal with all sizes from 23 to 300 horsepower.
Yeah, so I mean, you know when you want to you know look at a tire pressure or work under or near the tractor, you know you're going to need a safety system that gives you good confidence that. You know, when you're in that vulnerable position, there is no way it can move, you know, even with a cyber attack, because obviously if you're near the wheel and it moves even slightly, it's going to hurt. Yep.
Normally I would say I turn it off and that would be the end of it. But today I just saw an article about a mother who was pinned and her 18-month-old was killed by a tractor that was powered off. So it rolled over them.
Yeah. I mean, certainly if you've got some level of autonomy connected to it.
Farms are dangerous.
You need to make sure it's isolated as well as powered off. I mean, it's the only way you can be sure, really. Yeah. Especially when you're modifying the brake, which obviously you are to allow it to move. Yeah. Yeah, good question.
Yeah. That's interesting. Calculating the force it would take to cause damage and then make sure you're under that or take an account for that.
Yeah.
Yeah, I'll reference Fendt Xaver as I think that was their attempt to meet that need.
It was breaking up there a bit for me, but I don't know if it was for anybody else.
Yeah, it was breaking up for me too.
What was that, Kyler?
Xaver. Xaver. That was their attempt to avoid problems by making something. Nope, I can post.
Okay. Great. Thank you, Jonathan. It's a little bit like drinking out of a fire hose. There's a lot of information there. You got it all crammed in your head. That's amazing. But appreciate it. Thank you for being here tonight.
Yeah, thanks for having me. It's been a pleasure, guys. Thank you, Matt.
You bet. You guys have a great week, and we will see you next week.
Bye.
Thanks, man. Thanks, Jonathan, for your time.